General-purpose receptacles located at the landings of a high-rise hospital stairwell are required to be on an emergency branch circuit. This requirement stems from the critical need to maintain functionality of essential equipment and lighting during power outages, particularly in environments like hospitals where patient safety and operational continuity are paramount. The emergency power system in a high-rise hospital is designed to automatically supply electricity to specific loads within a few seconds of a power failure. This ensures that critical systems such as life support equipment, operating room lighting, and fire alarm systems continue to function without interruption. Receptacles in stairwells, specifically at landings, are included in this emergency power system to support the use of equipment necessary for evacuation, rescue, and communication. Several factors contribute to this requirement. Firstly, stairwells are primary evacuation routes during emergencies such as fires or natural disasters. Maintaining adequate lighting and the ability to power communication devices in these areas is crucial for guiding occupants to safety. Secondly, hospitals operate around the clock, and stairwells may be used by staff and visitors at any time of day or night. In the event of a power outage, the emergency lighting powered by the backup system ensures that stairwells remain illuminated, preventing accidents and facilitating safe egress. Thirdly, emergency personnel, including firefighters and paramedics, may need to use stairwells to access different floors of the building during an emergency. Having readily available power outlets allows them to operate equipment such as portable radios, lighting, and medical devices, enhancing their ability to respond effectively. The National Electrical Code, or NEC, provides guidelines and regulations for electrical installations in buildings, including hospitals. While the specific requirements may vary depending on the addition of the code and local amendments, the general principle is that emergency systems must be designed to ensure the safety of occupants and the continued operation of essential equipment. Article 700 of the NEC covers emergency systems and outlines the requirements for the source of power, distribution, and control of these systems. Section 700.12 addresses the types of acceptable power sources for emergency systems, which may include generators, batteries, or uninterruptible power supplies or UPS. Generators are commonly used in hospitals due to their ability to provide a reliable and long-lasting source of emergency power. Batteries and UPS systems may be used to supplement generators or to provide short-term backup power for specific loads. The NEC also specifies the types of equipment that must be connected to the emergency system. Section 700.8 requires that emergency lighting be provided in stairwells, corridors, and other areas used for egress. This lighting must be arranged to provide illumination automatically upon failure of the normal power supply. In addition to lighting, receptacles in stairwells may be required to be connected to the emergency system to power communication devices, medical equipment, or other essential equipment. The design and installation of emergency power systems in hospitals must comply with the requirements of the NEC and other applicable codes and standards. This includes the selection of appropriate equipment, the proper wiring and grounding of circuits, and the testing and maintenance of the system. Regular testing and maintenance are essential to ensure that the emergency power system functions reliably when needed. Hospitals typically have detailed procedures for testing their emergency generators and other backup power systems. These procedures may include periodic load testing, where the generator is operated under a simulated load to verify its performance. Transfer switches that automatically switch between the normal power source and the emergency power source must also be tested regularly to ensure that they operate correctly. Furthermore, the batteries used in UPS systems must be inspected and replaced as needed to maintain their capacity. The electrical plans for a high-rise hospital should clearly indicate which receptacles are connected to the emergency power system. These receptacles are typically identified with a distinctive color or marking to distinguish them from normal power receptacles. The emergency power circuits are also typically isolated from the normal power circuits to prevent a fault in the normal power system from affecting the emergency system. The use of automatic transfer switches ensures a seamless transition from normal power to emergency power in the event of a power outage. These switches continuously monitor the normal power supply and automatically switch to the emergency power source if the normal power fails. The transfer switches are designed to minimize the interruption of power to critical loads during the transfer process. In addition to the NEC, other codes and standards may apply to the design and installation of emergency power systems in hospitals. These may include state and local building codes, as well as standards published by organizations such as the National Fire Protection Association or NFPA and the Institute of Electrical and Electronics Engineers or IEE. The NFPA 101 Life Safety Code provides requirements for the protection of life from fire and other hazards in buildings, including hospitals. This code addresses emergency lighting, exit signage, and other features that are essential for safe evacuation. The IEE standards provide guidance on the design and testing of electrical systems, including emergency power systems. Compliance with these codes and standards is essential to ensure that the emergency power system meets the required level of safety and reliability. The design of emergency power systems in hospitals is typically performed by qualified electrical engineers who have experience in healthcare facilities. These engineers must consider the specific needs of the hospital, the applicable codes and standards, and the available equipment and technology. The design process typically involves creating detailed electrical plans, specifications, and calculations to ensure that the emergency power system meets the required performance criteria. The installation of emergency power systems is typically performed by licensed electrical contractors who have experience in healthcare facilities. These contractors must follow the electrical plans and specifications and comply with all applicable codes and standards. The installation process typically involves wiring circuits, installing equipment, and testing the system to ensure that it functions correctly. The inspection and approval of emergency power systems are typically performed by local building officials or other qualified inspectors. These inspectors verify that the installation complies with the applicable codes and standards and that the system functions correctly. The inspection process may involve visual inspections, functional testing, and review of documentation. The ongoing maintenance of emergency power systems is typically performed by qualified technicians who have experience in healthcare facilities. These technicians perform regular inspections, testing, and repairs to ensure that the system functions reliably. The maintenance process typically involves checking the batteries, generators, transfer switches, and other components of the system. In summary, the requirement for general-purpose receptacles at high-rise hospital stairwell landings to be on an emergency branch circuit is a critical safety measure. It ensures that essential equipment and lighting remain functional during power outages, supporting safe evacuation, rescue efforts, and communication. Compliance with the NEC and other applicable codes and standards is essential for the proper design, installation, testing, and maintenance of these systems. This comprehensive approach ensures the safety and well-being of patients, staff, and visitors in the event of a power emergency. The selection of the appropriate emergency power source is another important consideration. While generators are the most common choice for hospitals, other options such as batteries and UPS systems may be suitable for certain applications. The choice of power source depends on factors such as the size and type of load, the required runtime, and the available space and budget. Generators are typically powered by diesel fuel, natural gas, or propane. Diesel generators are the most common choice for hospitals due to their reliability and long runtime. Natural gas generators are a cleaner alternative to diesel generators, but they may not be as reliable in areas with frequent natural gas outages. Propane generators are a portable option that can be used in areas where diesel or natural gas is not available. Batteries are typically used to provide short-term backup power for critical loads such as computers and medical equipment. UPS systems combine batteries with power conditioning equipment to provide a clean and stable power supply. The size of the emergency power system must be sufficient to meet the needs of the hospital. The total load on the emergency system is determined by adding up the power requirements of all the equipment that will be connected to the system. The emergency generator must be sized to provide enough power to meet this load, with a margin of safety to account for future growth. The distribution system for the emergency power system must be designed to ensure that power is delivered reliably to all the connected loads. The distribution system typically consists of a series of panel boards and circuit breakers that distribute power to the different areas of the hospital. The emergency power circuits are typically isolated from the normal power circuits to prevent a fault in the normal power system from affecting the emergency system. The control system for the emergency power system must be designed to automatically switch between the normal power source and the emergency power source in the event of a power outage. The control system typically consists of a series of automatic transfer switches that continuously monitor the normal power supply. If the normal power supply fails, the transfer switches automatically switch to the emergency power source. The control system may also include features such as remote monitoring and control, which allow hospital staff to monitor the status of the emergency power system and to start or stop the generator remotely. The testing and maintenance of the emergency power system are essential to ensure that it functions reliably when needed. The testing and maintenance procedures typically include regular inspections, load testing, and battery testing. Regular inspections are performed to check for any signs of damage or wear. Load testing is performed to verify that the generator can provide enough power to meet the needs of the hospital. Battery testing is performed to verify that the batteries are in good condition and can provide the required backup power. The results of the testing and maintenance are documented and any problems are corrected promptly. The emergency power system is a critical component of a hospital's infrastructure. It is essential to ensure that the system is properly designed, installed, tested, and maintained to protect the safety of patients, staff, and visitors. The requirements for emergency power systems in hospitals are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that the hospital's emergency power system meets the required level of safety and reliability. The increasing reliance on electronic medical equipment and the growing demand for uninterrupted power have made emergency power systems even more critical in hospitals. Advances in technology have led to the development of more efficient and reliable emergency power systems. These systems are capable of providing seamless transfer of power, improved power quality, and enhanced monitoring and control capabilities. As hospitals continue to evolve, emergency power systems will play an increasingly important role in ensuring the safety and well-being of patients and staff. The use of uninterruptible power supplies or UPS systems is becoming increasingly common in hospitals to protect sensitive electronic equipment from power disturbances such as voltage sags, surges, and blackouts. UPS systems provide a clean and stable power supply, which is essential for the proper functioning of medical equipment such as patient monitors, diagnostic imaging systems, and laboratory equipment. UPS systems are typically used in conjunction with generators to provide a comprehensive emergency power solution. The UPS system provides short-term backup power during the transfer from normal power to generator power. The design of the emergency power system should also consider the potential for future expansion. The system should be designed to accommodate the addition of new equipment and loads as the hospital grows. The electrical infrastructure should be designed to support the increased power demand. The location of the emergency power equipment should be carefully considered. The equipment should be located in a secure area that is protected from flooding, fire, and other hazards. The area should be well ventilated to prevent overheating. The equipment should be easily accessible for maintenance and repair. The installation of the emergency power equipment should be performed by qualified electricians who are familiar with the applicable codes and standards. The installation should be inspected and approved by the local building officials. The commissioning of the emergency power system is an important step in the process. The commissioning process involves testing the system to verify that it is functioning correctly. The testing should include load testing, transfer testing, and battery testing. The results of the testing should be documented and any problems should be corrected. The emergency power system should be integrated with the hospital's building management system. This allows the hospital staff to monitor the status of the system remotely and to receive alerts in the event of a problem. The building management system can also be used to control the operation of the emergency power system. The hospital should have a written emergency power plan. The plan should outline the procedures for responding to a power outage. The plan should identify the critical loads that must be powered during a power outage. The plan should also specify the roles and responsibilities of the hospital staff. The hospital staff should be trained on the emergency power plan. The training should include instruction on how to operate the emergency power equipment and how to respond to a power outage. The emergency power plan should be reviewed and updated regularly. The hospital should conduct regular drills to test the effectiveness of the plan. The emergency power system is a complex and critical system. It is essential to ensure that the system is properly designed, installed, tested, and maintained to protect the safety of patients, staff, and visitors. The requirements for emergency power systems in hospitals are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that the hospital's emergency power system meets the required level of safety and reliability. The receptacles need to be on emergency power to provide for emergency usage, and that applies to stairwells. And this includes the landings of the stairwells. This is critical for a high-rise hospital.